Hi everyone! This is a tutorial video for simulation of frequency modulation using Matlab Simulink. But before I proceed to simulation, let me first give you a few information regarding frequency modulation. What is modulation? Modulation refers to converting the information signal to a suitable form of transmission. In communication system, the message or the information signal is converted to the electronic signal, which is transmitted through the communication channel to the receiver. Then what is frequency modulation? Frequency modulation is a modulation in which the frequency of the carrier wave is altered in accordance with the instantaneous amplitude of the modulating signal, keeping pace and amplitude constant. It means it varies the frequency of the carrier in proportion to the message or data signal while maintaining the other parameters constant. What does a carrier wave do? A carrier wave is a carrier signal, or just a carrier. It is a waveform, usually sinusoidal, that is modulated or modified with an information-bearing signal called the message signal or modulation signal for the purpose of conveying information. How does FM modulation works? For example, in radio, in order to create a frequency modulated wave, the frequency of the radio wave is varied in accordance with the amplitude of the input signal. When the audio wave is modulated with that of the radio frequency carrier signal, then the generated frequency signal will change its frequency levels. The variation by which the wave moves upward and downward is to be noted. This is termed as deviation and is generally represented as kilohertz deviation. Now, let's proceed with the simulation using Matlab Simulink. Open the Matlab app. Click Simulink. Choose Create Model, a blank model. Then click the library browser and choose Simulink. In building Simulink model, first, we need to have a message signal source, and it is a sine wave. We can find sine wave in sources. Choose the sine wave block, drag, and drop. Then, we need to connect the sine wave in a gain. We can find gain in math operations. By the way, the purpose of gain is it multiplies the input by a constant value. Then connect. Then after this, we need a sum block, which is also located in math operations. The purpose of sum block is just summing inputs. We also need a constant. A constant is, we can find constant also in sources. A constant serves as a frequency carrier, and also the other purpose of constant is just an input by a constant value. Next is we need to put an integrator. And integrator is in continuous. The purpose of integrator is it integrates an input signal with respect to the time and provides the result as an output signal. And now, we have to connect the integrator into a gain. Again, we can find gain in math operations. Then next, we have to connect this into a trigonometric function, which can be found also in math operations. And by the word itself, the purpose of trigonometric function block is just performs numerous trigonometric functions such as sine, cosine, tan. And then next, we need to put again a gain. Gain also in math operations. And then lastly, the scope. We can find scope in sinks. By the way, the purpose of scope is it display the simulation data or the capturing data, also known as oscilloscope. You can make it bigger if you want. Since it displays the waveforms, it is much better if we also connect this here between the message signal source and between the gain, so that we can also see the waveforms coming from this source. So we need to modify the scope. Make it 2 for us to be able to connect these into two inputs rather. Now let us configure each blocks. First, I want to format it into an auto name, to a name on sine wave. Let's use a time base, then use simulation time. Amplitude 1, pi 0, frequency, make it to pi. For the phase 0, and for the sample time, let's use 1/1000. Apply OK. Do not forget to click apply OK. Next, for the gain, let us make it 50. Apply OK. And for the frequency carrier, the constant, let's make it 100. Apply OK. We do not need to change the sum, the integrator, the gain. And for the trigonometric function, let's see if it is on sine. Okay. Don't have to need We do not have to change the gain key. Now, let's run the simulation. And let's see the waveforms in scope. As you can see, there are two waveforms overlapping. So what we need to do is configure it in view, layout, choose two blocks. Now these are the waveforms. Let us zoom the modulated signal so that we can see the waveforms clearly. The signal that you can see in upper part is the input signal, while in this lower part, this is the FM signal, the modulated signal. In this non-compressed part, it is where the low frequency change, and in this compressed part, it is the high frequency change. So this is the frequency modulation simulation using Matlab Simulink.